welcome to today's third session, this third day of the disaster management course. And today we are being joined by Mr. Srinivas Rao D. He was earlier with us as assistant director in IRIDIM Bangalore, the Indian Railway Institute of Disaster Management Bangalore. And there he always got very good feedback for his classes on railwheel interaction, Neral's formula, and ART, ARIMEE movement, equipment, and their maintenance. And that is why now that he has left IRIDIM to become AME Diesel at Krishnarajpuram Diesel Shed in SWR, we still request him to spare his time from time to time. And I'm very happy to say that today, Mr. Srinivas has been able to spare some time for us to take this class again. So thanks a lot, Mr. Srinivas, for your time today. And to the participants, I hope that all of you will interact because this is one of the most technical classes of this particular course, and it is something that most other participants have all found very interesting in the other courses. Mr. Srinivas has taken this class in our disaster management course for the last 1 year or so. So thank you once again, Mr. Srinivas. And participants, please interact. Please ask as many questions as possible. And please let this be a two-way interaction. Now, without spending any more time, I think because Mr. Srinivas's time is also quite valuable. So, Mr. Srinivas, you can please start. Thank you.
All right, sir. Thank you very much. So, good morning, all the participants.
Good morning.
So, I hope I am audible to you all. Am I audible?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Right. So already sir has given a brief introduction about me. So I will also give some more introduction. So my name is Srinivas Rao. I worked as a breakdown in charge for about 10 years in Mysore division, especially. So where we have different stock like we have MRV, that is ARMV, we have ART, and we have 140-ton crane. So all these facilities are there. So I was the in charge for the ARMV for all this one as a depot in charge also. I maintained there. So stock. Okay. So in railways, as you are aware and attending this class, so derailments, accident. Am I audible to you all?
Yes, sir. Yes, audible, but the sound is having noise, sir.
Noise.
Sound is not clear.
सर योर साउंड इज क्लियर प्लीज आप अपना तरफ से थोड़ा प्लीज चेक करिए नहीं होने से अदर सर लिसनिंग सर साउंड इज वेरी क्लियर आपका तरफ से
Okay, the sound is quite clear, and please mute your microphone, Mr.
Others, please mute your mics so that you can clearly listen my voice.
And the sound is absolutely clear, Mr. Srinivas. Please go ahead.
Okay, sir, please start.
Right. So, in our railways, so derailments is a common phenomena. Once a derailment or accident is happened, then the next step is the ARME staff has to reach the spot. After reaching the spot, so they will be forming into different gangs. So I'm talking about mainly mechanical, so different gangs. So one gang of supervisors and staff will be concentrating on re-railing work. Another gang, if any passengers are involved in the accident, so for their restoration and then producing before the qualified doctor. So this is the work we are doing. Apart from these two, the other work also it is there. So that is called joint readings. So joint readings means the readings at the time of accident. So how they were. So what may be the reason for the accident cause? So this is also the another important area. So one has to, that means those who are involving in the breakdown specials, both officers and supervisors has to concentrate. So whether the problem is with the wheels, whether the problem is with the track, so whether the problem is any other issue, that may be a natural calamity or some boulders fallen or any breach. Okay, so like this, various reasons are there to find out the reason for the derailment. So in order to find out a cause for the derailment, so everybody must have some knowledge. So on the topics like this, so that is rail wheel interaction. So rail wheel interaction, what we are going to discuss now, it is the basic topic. It's a basic topic for all engineers, especially mechanical, and any engineer can learn. So these things perfectly about these derailment phenomenon or cause of the derailment. Before coming to that picture, so you must understand minimum basic knowledge on this. So derailments generally are broadly classified into two varieties. So one is called a sudden derailment, another is called a gradual derailment. So sudden derailment means, so it will not give any clue, so directly it will fall. So that means, so due to sudden shifting of load, excessive speed on a curve or turnout, broken wheels or springs, or a track utterly failing, or any vehicle component, or any obstruction on the track. So these are all some of the reasons for the sudden derailment. So sudden derailment, it is easily be identified. So what was the reason for this derailment? Many of the times we can give the prima facie immediately for this reason for the sudden derailment. But whereas to arrive at the cause of the derailment, the gradual derailment plays an important role. So gradual derailment means, so it will mount over the railway, a rail table, then it will move certain distance, then after that it will derail. So that means we will be having both the point of mount and a point of drop, both will be there. And what was the reason for this derailment is somewhat difficult. So those who are in the basic stage and all, so it is very difficult. So gradual derailments are very, very important to understand. So in this, the track may be the reason, track defects, or vehicle defects may be the reason, or unfavorable operating features also. So one of the reasons for this gradual derailment. So the topic what we are going to discuss is applicable for gradual derailments. So how the gradual derailment takes place and what are the forces contributing for the gradual derailments. So in today's topic, this only we are going to discuss, that is gradual derailment and how it will take place, what are the various forces that are acting on a gradual derailment cases. So that is only the important topic. So that is also called as rail wheel interaction. In the short form, we can call it as rail wheel interaction. So this rail wheel interaction only now I'm going to tell you. So in the second session, we'll talk about what are the MRV, what is ART, these things and all we'll discuss. So first we'll concentrate on rail wheel interaction. So rail wheel interaction, once again I'll tell you, is a basic tool to understand the derailment reasons. So from this only the analysis can be made. So in order to understand, for example, you can see here one photo I'll show you. So this is the derailed condition. So one coach is in the derailed condition, you can see. So here this wheel is supposed to travel over this rail table, but whereas this came out from the rail table and caused the derail. So what are the effects, how it will come out from the rail table? So these things only we are going to discuss in today's class. So in order to understand better, so I feel that so you must understand minimum knowledge on the wheel and minimum knowledge on the rail also it is needed. So for that, so I will discuss about those who are already known, it is no issue. So those who are not known, so some other additional information also you may get it. So please try to understand, it will not be repetitive for you. So first come to the rail. The rail profile in Indian Railways will look like this. This is the rail profile. So generally, everybody will be seeing the rail profile, but a lot of things are there in the rail profile. So this rail profile is also called as flat-footed rail. These are all flat-footed rail. So from the last 20-30 years only we are using. So earlier and all, so there are different types of rails we are using. So in rails, in Indian Railways, so we were having different varieties. So one important varieties, what are those important varieties we'll discuss now. So one variety of rails is called 52 kg rails. So this is the 52 kg rail what we are seeing now. This is the 52 kg rail. But generally, strictly speaking, it is not correct. 52 kg means it is 52 kg per meter rail we have to specifically must say. So that means for a 1 meter length of a rail piece, if you take it and weigh it, 1 meter length piece, if you weigh it, if it is approximately 51.9 or 52 in that surroundings, if it is there in that vicinity, so then such type of rail will call it as 52 kg per meter rail. So these rails nowadays railway board is taken decision to withdraw these 52 kg per meter rails. So now they are started introducing the one more type of rail called 60 kg per meter rail. So this is the present day trend going on. So 60 kg per meter rail. So 60 kg per meter rails are nowadays we are using. So 52 kg per meter rail, if their life is completed or order life is completed, so they should not replace with 52 kg. They have to replace with the 60 kg per meter rails only. So in the 62 kg per meters also, then one more it is getting. So that is called 60 kg per meter rail. And once again, this is the modified version is also coming. Modified. So this is from the last 2 years or 1 year, we are seeing this variety that is 60 kg per meter rail. So these are the 3 varieties. But in the case of a DFCCIL and all, they are also using the rails 68 kg per meter rail. So Indian Railways not adopted 68 kg per meter. So in future, so it may be we are changing to 68 kg per meter also. So first I will explain about the little reasons for this introduction of this one. So 50 then the older rails and all I'm not talking. I'm talking about only broad gauge rails. Okay, in meter gauge rails and 90R. Okay. 75R, those things and all meter gauge rails, that and all I'm not talking about. These are all old. So I'm talking about only new trend. So 60 kg per meter modified, 60 kg per meter, 52 kg per meter rails only we are using. So here the difference between these things are 52 kg per meter rails. So they will be having the GMT. So GMT means a gross million ton of load. So that means how much load they can bear. So this is about 525 GMT was there. So now they are modified into 800 GMT was the life. This is one reason you have to understand. GMT 800 GMT. 60 kg per meter and all 1000 up to 1000 GMT they are keeping on the track. This is up to 1000 GMT. Even 60 kg modified also up to 1000 GMT. 68 kg per meter and all still beyond that. So this gross million ton means it will give you per every year. So our civil engineers and all. So how much traffic is moved over that rail tables, they will take it the account. Say for example in the A-class routes. A-class routes means the train starting from Chennai to New Delhi. So that is called A-class route. A-class route GMT per year will be roughly 70 to 80 GMT will come. So 80 GMT, 525 GMT divided by 80 GMT if you are dividing. So you are getting number of years of service they can be laid on the track. So after that they have to renew that particular track of either 52 kg. 60 kg means 1000 GMT divided by that 80 GMT per year or 100 GMT per year. So whatever it is there, 10 years or 12 years and all, it will be there. So this is one way of expressing the rail structure. Then one more important point to be noted is this 52 kg per meter rails are having the axial load capacity. So axial load capacity, they proved that so 22.5 tonnage of okay, axial loads only it will take 22.5 ton. So, but on paper, they are giving up to 25 ton, okay, axial load it will bear, but there is a one paper on this, okay, 52 kg per meters, so they cannot withstand beyond 22.5 ton axial load, okay. So I hope everybody knows what is an axial load. Once again, I'll explain. Axial load means, suppose if you take a one small, say diesel engine, so this is the diesel engine. So diesel engine will be having front truck will be having 3 axles. So rear truck also will be having 3 axles, 6 axles will be there. If you take one, say WAG 9 locomotive, WAG 9, WAG 9 locomotive. So WAG 9 locomotive, the weight is 132 ton total weight, 132 ton. So total weight I am talking. So total including our axles, everything. So upon axles, number of axles is 6. So it will comes around, so 2, 6 are 12 and 22 ton. So that means, so you can run these WAG 9 locos on the 52 kg per meter because it is designed for an axial load of 22.5 ton. So safely you can move. So because they are also getting a doubt as and when the wear and tear as well as life is go on taking place. So there are cases of breakage also. So that is why they are shifting from 52 kg per meter to 60 kg per meter. So this is something like a ICF coaches to say LHB coaches, how we are transforming. So 52 kgs to 60 kg per meter. So they are transforming. So that is the trend nowadays. Even our wagons also. Suppose if you take a example of a wagon. So wagon, if you take it as say box and wagon or BCN wagon and all. So box and wagon, its empty weight will be roughly some 23 ton will be there. So over this we'll put around 66 ton roughly. So it will becomes around some 90 ton. So 90 ton will be carried by, I'm talking about loaded wagon. So 2 front axles and rear 2 axles. So 90 ton divided by 4. So it will not tolerate this much of load, 90 ton. So 90 divided by 4, roughly some 2. So 22 point something. So almost we are touching the design capacity of the 52 kg per meter rate. So therefore, sometimes there is a chance of rail breakage or our wheels also will become hot axles. So various reasons all will come if you are running almost the designed load and all. So that is why Railway Board has taken a decision. Hereafter, whatever the rails we are providing on Indian Railway track, either for new rails, okay, or replacing of the old rails and all, we have to adopt 60 kg per meter rails only. So therefore, hereafter we will see in all railways 60 kg per meter. I am talking about main line. So it may be loop lines and all. So it may be permitted even 52 kg per meter also because still their life is there. So this is one way of understanding the rails, 52 kg per meter, 60 kg per meter and all. I hope everybody following what I am teaching.
Yes, sir.
Yes, okay, right. So 60 kg per meter modified, this is also 60 kg per meter. So in this only profile is changed and also they are following the LWR track and all. So for that reason only they brought the 60 kg per meter. So last 1 year only this is approved design for 60 kg per meter rails. So this and all if time permits we'll discuss a little later. So now what is required for this topic only I will discuss with you. And 68 kg per why DFCCL are taking means, so DFCCL corridor, so their main motto is to run only freight traffic. So freight traffic means they wanted to run even say double stack containers and all. So double stack containers and all axial load. So not only this 90 ton and all, it will go beyond 100 and all. So beyond 100 ton, 100 divided by 4. So it will not tolerate our 52 kg and 60 kg in the long run. So therefore, they adopted now itself the 68 kg per meter. So 68 kg per meter now in Indian Railways not adopted. What as far as so my areas is Southwestern Railway, so no, so far not adopted. I do not know about other railways whether they are adopted. So as per my knowledge, so 68 kg per meters and all not adopted by Indian Railway. Only first three are there: 52 kg per meter, 60 kg per meter, 60 kg per meter modified. So in this, the 52 kg per meter, so almost 30 to 40% of the track of the Indian Railways, so it is still under 52 kg per meter. So the remaining 60% of the track is converted to this one as well as this one. Okay, either a second one or third one, 60 kg per meter or 60 kg per meter modified track. So keeping this one, so what is important for this topic is, so you have to understand what are the various parts of a 52 kg rail profile. So now this will call it as hereafter, I'll call this as a rail table. This is called as a rail table. This top one will call it as a rail table. The side one will call it as a rail head. This is also similarly rail head. So this portion, lean portion, that is called a rail web portion, will call. This bottom portion will call it as a rail foot. So these are the important parameters you have to understand: rail table, rail head, rail web, rail foot. Then here in rail head also there are two faces. So this is one face, this is another face. So these faces also are having a different names. So that faces are called as, one is called as gauge face, the another side is called a non-gauge face. So hereafter I will talk about what is gauge face and non-gauge face. So gauge face means gauge is measured here only, and also our wheel, say this is the wheel, for example, this is the wheel, this is the wheel. So wheel flange, I repeat, wheel flange will come, okay, towards the face of the rail. So that particular face will call it as a gauge face. So where flange, generally the gauge, where the flange will not sit there, only the tread area will sit there, that is called as non-gauge face. I hope it is clear what is a gauge face and non-gauge face. Gauge face means, I repeat, where flange will sit, that is called a gauge face. Where flange will not sit there, so that is called a non-gauge face. So these two are very important for the rail wheel interaction: gauge face, non-gauge face. Okay, so assuming that you know what is a gauge face and non-gauge face, so how to identify means by seeing the track, so we can say that what is the gauge face and non-gauge face. Okay, I'll show you for you. So in this, so this is called, so in this picture, this is called a gauge face of the rail. This is the non-gauge face of the rail. This is the gauge face. This is the non-gauge face. Okay. Why? Because flange is this side. This side is the flange. So for this rail, it will be opposite. So that means inner will be the gauge face, the outer will be the non-gauge face. Okay. So gauge face and non-gauge face, it is clear to you. So first you have to understand what is a gauge and how this is measured, because many of our engineers, okay, who are all working in the field, sometimes they are hesitating to come to join the breakdown specials and all. So the reason is, so they are not having much knowledge. So many of them. So for that reason only I'm telling. So what is a gauge actually? So gauges, there are two varieties. One is called track gauge. Another is called as wheel gauge. So first I am talking about what is a track gauge. So here you have to understand the track gauge means this is the rail. This is you may imagine this is the left rail. This is the right rail. Okay. So over this our wheel set is moving over here. So over this rail, say this is the rail table, and similarly this is the rail table. So from this rail table, 13 mm below, exactly 13 mm, I repeat. So 13 mm below here, and similarly 13 mm below here. Okay. If you make a point at this head area, rail head area, So this is called inner faces, inner gauge faces.
सर ये वाला वापस
Yes,
स्टार्टिंग से
please.
बताइएगा
हाँ?
सर ये वाला वापस स्टार्टिंग से बताना ये
हाँ,
गेज
ठीक है,
नापने
ठीक
का
है।
क्योंकि वो जो स्लाइड थी ना वो पहले डिरेलमेंट वाली लगी हुई थी
हाँ,
अभी
नहीं,
चेंज
ठीक है, ठीक है, ठीक है, राइट, ठीक है, okay. I'll repeat. Track gauge. So track gauge is how much? So generally track gauge means we'll be discussing about say broad gauge, meter gauge, okay, narrow gauge and all. So now I'm discussing about broad gauge. I'm not discussing about the meter gauge and narrow gauge and all. I'm not telling you. Okay, here whatever the discussion is there, I'm making on the broad gauge. So in the broad gauge, so how to measure the gauge means here, once again, this I will rub it off. Once again, I will draw. Is my annotations are visible to you? Whatever I'm writing here, is it visible?
Yes.
Right. So here you draw one line and here you draw one line. Just the 13 mm below, 13 mm below here and 13 mm below here. So you make a point. Okay, here one point, here one point. Okay, so I'll repeat, okay, by rubbing off this. So once again, I'll mark the point. So you take a point 13 mm below here, 13 mm below here, 13 mm below here. Join these 2 points. So this value must be 1676 millimeters. So on record, this is the thing they have to maintain. 1676 millimeters is the track gauge they are supposed to maintain. So unofficially, our civil engineers are maintaining even 1673 mm also once the PSC slippers are started, but they are not revealing it. So now and on record what is there, that only we'll talk about. So in the books and all, they are mentioning only the gauge is 1676. So here also we'll take it as 1676 only. So off the record and all, how they are maintaining, that we'll leave it to them. So 1676 means it is called as correct gauge. So gauge correct means the value must be 1676 mm. If it is there, so that gauge is called as correct gauge. Okay. Then if it is more means, for example, say 1680 if it is there, so that means it is more by plus 4 mm. So therefore this gauge will call it as a slack gauge. I repeat, if gauge is more than the standard gauge, so standard rail gauge, that will be call it as slack gauge. So if slack gauge word means it is a or loose gauge or slack gauge, whatever you can terminology you can use it. So slack gauge, by how much slack? It is 4 mm. So how the 4 mm you are getting? So we are comparing with the 1676 standard gauge. Since we have 1680, so plus 4 mm more. So therefore it is called a slack gauge by 4 mm. Suppose if it is less, say for example, you measured a 1670 if it is there. 1670 means minus 6 mm. So this is called as tight gauge. This is called a tight gauge. So tight gauge means it is lesser by some value, okay, in comparison with the 1676. So 1676 is the standard. So इससे कम रहने से इसको कहेगा tight gauge, इससे ज़्यादा रहने से slack gauge. Okay, I hope what is the meaning of slack gauge, what is the tight gauge, what is the correct gauge. Okay, is it clear to you all?
Yes, sir.
So correct gauge means how much?
1676.
Right. Okay. So what is the tight gauge?
Sir, 1670.
Okay, anything less than 1676. I mean, okay,
Anything less than 1676.
Okay, 1675. So it means tight by 1 mm. Okay, that way you have to understand. So above 1676 we'll call it as a slack gauge. Below 1676 we'll call it as a tight gauge. Okay, so now in Indian Railways straight tracks. Okay, Indian Railway straight track. So straight track, this is the straight track. So on this straight track, So the permitted slack is -6 to +6. That means so they can give the tightness up to 6 and the slackness up to 6. So this is the permitted. Okay. So on straight tracks only. Okay. On a curved track, so this is the curved track. So this is the inner rail, this is the outer rail. Okay. So curved tracks and all, so it is permitted is up to 20 mm slack is permitted. Up to 20 mm slack is permitted. 20 mm slack means 1676 plus 20. 1686, 96 तक permitted. Okay, समझ में आया ना? Permitted है. Okay. Gauges, I hope you understood.
Yes, sir.
Right. So now I'm able to tell you about what is the track gauge, actually what is the standard gauge, and what is the slack gauge, what is the tight gauge, okay, and what is the permitted limits and all. I'm able to explain to you.
Sir, curve gauge, curve track पे sir ये tight gauge कितना permitted है?
Curve में tight gauge generally they will not maintain. So if at all maintain this only, -6 only. Normally curves they have to maintain slack gauges only. Slack gauges only they have to maintain. Okay. So otherwise it will lead to derailments and all. Okay. I hope it is clear to you. Any other doubts? Now I made you to understand what is the track gauge and what are the rail structure and different rails and all we have discussed. Now we'll discuss about the wheel also. Okay. So this we'll call it as wheel set. This hereafter we'll call it as wheel set. So what is my wheel set means? So two wheels will be there, right side one wheel, left side one wheel, and the center one axle will be there. This total we'll call it as wheel set. Okay. Hereafter this total I'm calling it as wheel set. Wheel set. So wheel set means so wheels, okay, along with the axle. Okay, along with the axle, this will call it as wheel set. Total is wheel set. Okay, consisting of two wheels, both the sides. This is called right wheel. This is called left wheel. Okay, left wheel. So total we'll call it as one wheel set. Okay, so now once we'll know the what is a wheel set and all, now we'll discuss about what is wheel profile. What is wheel profile also we'll discuss. So this and all many of you already learned. So for them it is a repetition. So those who are not remember, just please see once again. Say this is a this will call it as wheel profile. Okay. So in wheel profile, normally we'll be having different terminology. So this area we'll call it as a wheel tread, or shortly we can call it as a tread only. This is the tread. So this portion we'll call it as a flange portion. Flange portion. And where flange means from hereafter. Hereafter this is the flange. Okay. And where these two are separated, this is called a root. Tread, root, flange. Okay, this and all everybody knows. Okay, everybody knows?
Yes, sir.
Right. So now in this some more information also everybody must know. This thickness, can anybody tell?
63.5 something.
Any other guesses?
127, sir. Mm.
Yes. So one person told it is correct only. So 127. mm. Right. So in the coaching and wagon, we are maintaining this width of the wheel is 127 mm is true. But in the case of a locomotive, so I'm right now I belongs to the loco. So we are maintaining 134 mm. 134 mm we are maintaining for this loco wheels and all. Loco wheels, we are maintaining 134 mm of the same value. So actually, first initially it was 127 only. So 127 by 2, it will give you 63.5. So that means whenever you are asked to measure, in the case of accident, whenever you are asked to measure, so what is the wheel dia? So wheel dia is to be measured at 63.5 mm only. You have to measure 63.5 mm place only. You have to measure the wheel dia. That means from this side, okay, this will be 63.5 mm only. Irrespective of whether it is a loco wheel or a coaching wheel or a wagon wheel. So from this face, we have to measure the 63.5 mm. Okay, this even though loco wheels are 134 mm and all. Okay, we are to be measured 63.5 mm only. We have to measure the wheel dia. Wheel dia to be measured here only, in this area only. We have to measure, not from here, not from this side. We have to measure from this side. Okay, so 63.5. This may be little more also we are keeping. That means, so as I said to you, this will be, we are maintaining for 134 millimeters. Okay, but even though 134 mm is there, so it does not mean that wheel dia to be measured 134 upon 2. So that is around some 67 and all. So it should not be. It should be 63.5 mm only wheel dia to be measured always. Whenever wheel diameter any technician or any person is measuring, wheel dia is to be measured from, okay, the flange side. Okay, from this face you have to measure 63.5 mm area. So what is the wheel dia? It's to be measured. Okay, so based on that, loco wheels means maximum 1092, and even for coaching wheels and all 915, based on the type of wheel, so that will be there. Okay, if it is a wagon wheel, 1000 mm will be there. So that and all different. So I hope you understand. So what is the wheel dia to be measured and where to be measured and all I told you. Then other things is, other things, once again I will draw the same, some more information I wanted to give over this. So we'll call it as a flange thickness. Everybody will call it as flange thickness. So how many of you know what is a flange thickness? And how much is permitted? Come on, one of you please answer my question. What is flange thickness?
28.5 mm.
How much?
28.5.
Okay, very good. 28.5 mm. So this is where exactly?
The complete radius.
Coaching.
Complete radius of the bottom side.
That means you are talking about this?
Yeah, exact.
No, it is not absolutely correct. Okay.
No.
Any other guesses?
Radius,
So flange thickness, if I say 28.5 mm, where exactly this? Any other guesses? It's a friendly class. Okay. So I am not a teacher and you are very less like that is not there. It's a friendly discussion. Okay. So don't worry about it, whether it is right or wrong and all. You are free to talk.
13 mm
not
below
the radius,
the flange.
diameter.
13
mm below the tip of the flange.
Okay.
Top portion say 13 mm below.
Right. So actually flange thickness is those who are not having a good concept, please understand. So from the tip, this is the tip of the flange. So from here, you measure the distance 13 mm. Here say 13 mm here. Okay, this is the 13 mm. 13 mm. So 13 mm, if you take a share of this piece, say this one you share off. Okay, so that means imagine that only the top piece is available. Okay, top piece is available. That means I mean to say here to here only available. So that distance, this distance, I repeat, this distance is called as flange thickness. Okay, I will draw. So one more time, so to understand better. So here 13 mm below. Okay, so this distance, this only, flange thickness. This distance only I'm talking about flange thickness. So in the coaching wheels and wagon wheels and all, so the maximum flange thickness we are maintaining it is whenever it is undergo the wheel profile. So we are maintaining 28.5 mm. This D, the D value only I'm talking, that is called as flange thickness 28.5 mm. Okay, but whereas in the loco sheds and all, so we are maintaining a 32 mm. The same value we are maintaining 32 mm. This is also called as thick flange wheels. This is called as thick flange wheels. Recently this trend is started. Okay, recently means last 5 years and all, this thick flange wheels we are starting. This is thick flange wheels. Thick flange wheels. So this and all normal flange. Okay, normal flange. 28.5 mm is normal flange thickness. Normal flange thickness. So in coaching stock as well as wagon stock, whenever the wheel is turned, so we'll maintain the wheel flange thickness of 28.5 mm. But in the case of thick flange wheels in the loco sheds and all, we are maintaining the 32 mm flange thickness. So I hope flange thickness, it is clear. Now can anybody tell me, so from this 28.5 mm, so today it is newly turned wheel. So it slowly what will happen means the flange thickness will become thinner and thinner. Okay, so up to how much thickness it is permitted?
22 mm.
Yes, exactly. So this 28.5 mm, slowly it will reduce as 28.5 mm after say 2 months 28, then after another 2 months say 27.5. So after another 2 months say 27. So like this it will go on reduces the flange thickness. So as and when it touches 22 mm for coaching stock as well as say loco stock and all, so we are permitting up to 22 mm. So 22 mm or lesser it is there, so we have to return the wheels. But for wagon stock and all, so we are going up to 16 mm permitted. For wagon stock this is permitted, wagon stock. For coaching stock this is the lower limit permitted. Coaching and loco stock and all, we are permitting 22 mm only. So I hope flange thickness, where exactly to be measured and what are the permitted limits and all, I hope you understand. Any doubts?
Sir.
Right. So now the some more data. So here if you see, here this tread portion, wheel tread portion, there will be a slope. There will be a slope we are maintaining. Can anybody tell what is the slope of this? And here also we are maintaining a slope. Can anybody tell me what is the slope of that area and what is the slope of flange area?
Red area 1:20.
This area how much?
1 is to 20.
Right.
1 in 20.
So 1 in 20 is the slope we are permitting. So in the case of a wheel tread area, we are permitting 1 in 20. Very good. So can you tell me what the slope we are permitting here?
1 in 2.5.
Correct. Exactly. 1 in 2.5. So in the flange, okay, area, we are permitting a slope of 1 in 2.5. In the case of a wheel tread area, 1 in 20 slope we are permitting. Okay, so those who are not known, please make a note of these things. Okay, it is very, very important. So similarly, on the rail table also, say, I told you, please see this picture once again. Here, once the track is laid, I repeat, once the track is laid, so you will get a slope of 1 in 20. But rails will not be maintained. This slope here, rail will not be like this. Rail will not be 1 in 20 slope. So this slope, how they are attaining is, here they are using sleepers. Here sleepers they are using. Say, this is the sleeper. This is the sleeper. So this sleeper will be maintained 1 in 20. I repeat once again. So this sleeper will be maintained 1 in 20 slope. Since over this any flat okay, a rail when you are placing then this will be tilted by 1 in 20. So that means indirectly our rail is also getting 1 in 20 slope and wheel is also will be having 1 in 20. I repeat. So 1 in 20 is an indirect way of getting the over the rail table. Okay, we'll be getting 1 in 20. How we are getting? Because once this is placed on a 1 in 20 sleeper, this is the sleeper. So what is sleeping under the rail, that we'll call it as a, say, sleeper. So sleepers nowadays, we are using a PSC type of sleepers. That is pre-stressed concrete sleepers. Some people will call it as a monoblock concrete sleepers. So whatever the name you can call it as. So these are all became a popular. Okay, nowadays the reason is, one of the reason is they wanted to follow the afforestation or deforestation to be avoided. So because earlier we used to maintain different steel sleepers, wooden sleepers and all. Wooden sleepers and all costly. You have to cut so many trees and all, and there we have to insert the sleepers here. Nowadays this is and all so gone era. So that nowadays we are using only PSC sleepers. Okay, so PSC sleepers when they are designed are molded, so they will maintain here 1 in 20. Okay, not the rail will be designed for 1 in 20. So rail automatically attains 1 in 20 once it is mounted over the sleeper. Okay, I hope it is clear. 1 in 20 will be there on the rail also. 1 in 20 slope will be there on the wheel also. Okay, I hope it is clear to you up to this. I hope you understood.
Yes, sir.
Yes, sir. Yes.
So now we'll go ahead with the subject. So now you can see this is the the real say wheel set over the rail table. Whenever you are keeping a wheel set over the rail table, so it look like this. Okay, so this we'll call it as a right wheel. This is the right wheel. So this is the right rail I can call. So this is the right rail. This is this one. So here this only we have discussed so far. So that is a flange area. Okay, tread area. Okay, where these two are joining. This is the root area. So this is the rail table. Okay, so I also told you about this is a non-gauge phase and this is the gauge phase. This is the gauge phase. Okay, so gauge phase will be there only this flange. Flange will be there only on the gauge phase. Okay, so I hope up to this, okay, you can understand. Any doubts up to this? Up to this discussion, any doubts for anybody?
No, sir.
Okay, right. So now we'll go little deeper into the subject. Right? Now, so this is the wheel, as I said to you. This is the rail. Once this wheel is mounted over the rail, okay, so this is a normal phenomenon, means always wheel will be over the rail table. Okay, rail table ke upar this wheel will be there, means it is on the track, you can call. If it is comes out only, it is called a derailment or accident, whatever it is there. So this is generally wheel and rail will be mounting this one. It is called a normal phenomenon. So whenever in the normal phenomenon, if you see, so between the flange, I repeat, between the flange and the rail head and the flange. So here if you, okay, observe closely, here you will be finding some gap. Are you able to see the gap, all of you? Are able to see the gap, all of you?
Sir.
I am talking about the gap between the flange as well as your rail. So rail gauge face as well as the flange thickness area, there is a gap.
19 mm, sir.
Huh?
19 mm.
वो no, उसके बारे में बताएंगे. Okay, I'll tell you. So are you able to see the gap, all of you?
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
So now this I will little zoom it. Okay. Are you able to see all of you here? Okay. Are you able to see the picture clearly?
Yes, sir.
I'm talking about this gap. I'm talking about this gap. This gap.
Sir, is it 19 mm?
I will explain what is that amount and all. Okay. So here there is a gap. There is a gap. So right side, okay, whatever the gap is there, so this is called a right side gap. Similarly, left side picture also I will show you. Okay, left side picture also I will show you. The same axle I have taken, same wheel set, this side, this side. You can see now. This gap. Okay. Are you able to see? All of you? Are you able to see the gap?
Yes, sir.
I will zoom it if you want. Are you able to see the gap here? Is flange touching the gauge face or not touching?
Not touching.
Not
Not touching. Right. That only I wanted. So this we'll call it as say left side gap. So hereafter I will use the word play. I will use the word play. Play. So this play left side it is there. So sigma L I will call. If it is right side, if it is there, okay, right play I will call. So both plays together, how much it will be there? Do you know? Anybody knows? Play
9.5.
left side, play right side. How much?
Total 19 mm, sir.
Okay.
One side
So
9.5
here,
and another 9.5.
okay. Right. So one of you telling say 19 mm. 19 mm is the right answer. But what is this 19 mm? How this 19 mm came? Also, I want to discuss you for 1 minute discussion. I have to make you. This is sigma L plus sigma R. Sir, good morning, sir. Sir, this is now only started, sir. So it will continue up to 12:30, sir. Between I'm giving 15 minutes gap. Yes. हुआ sir, start हुआ sir. May I come, sir, for 2 minutes? No, sir. May I come and again come back, sir, or may I continue? Okay, right. Good morning, all of you. Just I will take a 2 minutes time. Okay, I'll come back and join.